All right. Good to see you guys again. Well, I guess I can't see you, but you can hear my voice, and that's maybe good enough. Thanks for tuning in. Today we got triangle congruence proofs. Now, I know that proofs cause some anxiety for people, and that's okay if you feel anxious about them. I'm hoping that as we go through them it's getting easier, or at least as we do them together in class. My goal is to give you lots and lots of examples so that you can start to recognize patterns and then use those patterns in future proofs. So really it just takes experience and it just takes practice to kind of get the hang of it. So what I've got here for you is I got the first 3 proofs, and I'm going to go through those with you in detail, and then I'm going to give you hints on the other ones. Okay? All right, so let's start with number 1 here. Okay. Now, what we're trying to do is we're trying to prove a couple triangles are congruent, and that's true for all of these. And so what I'm starting with, I'm kind of looking at like my goal first before I do anything else. So I'm going to just kind of highlight the 2 triangles that I'm interested in, because in a lot of these images there's like extra lines and other stuff going on. The idea is to kind of get you to think, extra carefully about which triangles you're talking about and just be a little bit, be precise as you go through it. Okay, so those are the 2 triangles we're going to want to show are congruent. Now, we kind of talked about this in class a little bit in most classes, but if you missed that, what we know is we got x is the midpoint of BD. So this is point x right here, and there's DB. The midpoint, x being the midpoint, tells us that x is like exactly halfway. The way we define midpoint was that it's a point that cuts a segment into 2 congruent segments. So by using the definition of midpoint, you know you have congruent segments. Okay. It's also said in the given that x is the midpoint of C and of CA, segment CA. Okay, so these guys are congruent to each other as well, because again, midpoint means the point that cuts a segment into 2 congruent sections. I'm going to actually shade the triangles that I'm talking about. So the triangles that we're talking about are these 2 blue ones right here. Okay, so we already have side and side. Now, you might also recognize that these are vertical angles. Okay, so now we have side, angle, side, right? Side, angle, side. If 2 sides and an included angle of one triangle are congruent to 2 sides and included angle on the other side of another triangle, sorry, let me start over. If 2 sides and an included angle of one triangle are congruent to 2 sides and an included angle of a second triangle, then the triangles are congruent. That is the side, angle, side congruence postulate. Okay, we just got to take that reasoning and put it in a proof form. Now for these, I kind of like flow proofs. Some of you guys don't like those. You don't have to use a flow proof. You can also use a 2-column proof. I gave you that option. However, just the way I'm going to write it down here, I'm going to use flow because it makes a lot of sense in this case. If I'm going to prove these 2 triangles are congruent, and we just kind of figured out that we're going to do it by SAS, it makes sense to have a chain of reasoning for the first side, a chain of reasoning for the angle, and a chain of reasoning for the third side. So notice that if all these lines are converging to give me SAS, I have a line for S, a line for A, and a line for S. So that's my SAS right there. And I've kind of labeled them. Like, there's my first congruent side, BX congruent to DX. Now that midpoint is called X. I kind of shaded over it, but BX, DX, those are congruent, right? There's my congruent angle, CXD and AXB, these 2 guys, right? Just don't make sure you just got the naming there. And then the other side, that's AX and CX. Okay, so there's my side, there's my included angle. Okay, I just had to give a little background for how I got the sides, right? That was definition of midpoint. So I started with the given, then I used definition of midpoint to get the congruent segments here and here. And then this doesn't really come from the given, but I can just see from the picture that these are vertical angles. So I'm going to use the vertical angles theorem so that those angles are congruent. And there's my side, angle, side, all going in together to prove that those triangles are congruent. Okay. So again, you don't have to use flow proofs, but it makes a lot of sense to me because if I need 3 pieces of information to conclude the triangles are congruent, I'm just going to use 3 chains of reasoning to get there. And when those all converge together, I can finally show the triangles are congruent. All right. Now number 2, Okay, sorry, let me go back. Number one, you have to know definition of midpoint. Okay, so definitions, postulates, properties, and theorems, you're going to need to know some of those to get the right stuff here. Okay, and number two, there's a couple key pieces of information. The first one that I wanted to talk about was that Km, the segment, is congruent to JL. So that's actually huge. That means that this guy is congruent to this guy. So that's my first side right off the bat, right? So I said Km congruent to JL, that's my first side, right? Now you may not know that you're going to use side angle side yet, but I'm going to show you how you get all those. Okay, now the angle comes from the fact that these two lines are parallel, because that's also part of my given. Whenever I see parallel lines, my instinct is to look for alternate interior angles. So I got two parallel lines cut by a transversal, right? And so I'm going to have alternate interior angles congruent. Just to kind of make it a little bit more clear for you, because sometimes it's hard when you have extra lines in there. Basically what we have is something like this, right? Now of course you got to kind of turn it on its side, but these are the alternate interior angles that we have going on. Now to like complete our shape, essentially what we would have is we'd kind of like want to, I don't know, sorry, something like that, right? But those lines aren't important right this second. Okay, really we got these two parallel lines cut by this transversal, and we're going to say the alternate interior angles are congruent. Okay, and then the third side comes from the reflexive property. This side is actually part of both triangles. Okay, so we can say it's congruent to itself by the reflexive property. Now you might notice that I said Jm is congruent to Mj instead of Jm congruent to Jm. The reason why I did that is because these triangles are pointing in different directions. And so if I'm going to say a segment is like congruent to another segment, I want to say, like, I want to line up the corresponding like vertices. So J is kind of like, I don't know, if you were to flip this around, M would kind of line up with J, they would kind of correspond. So because the triangles are pointed in different directions, I kind of reversed the way they're written so that on the top triangle, vertex J corresponds with vertex M on the bottom triangle. Not super important, I guess, but that's why I did it that way. All right, so that's side angle side right there, right? I got, when I see the first side given, okay, perfect, and then I see the reflexive, and I'm like, okay, that's my second side, awesome, reflexive property, and then I'm like, oh, parallel lines give me alternate interior angles. So the side, the angle, excuse me, two sides and an included angle of one triangle are congruent to two sides and the included angle of the second triangle. Therefore, the triangles are congruent. Okay, so I'm just using side angle side. So I have a line for the first side, that's the given one. I got a line for the angle, I got that from alternate interior angles, and then I got a line for the second side, that's the reflexive property. And that's it, like that's all there is to this proof. So that's kind of cool. Okay, now the third one I kind of goofed on, and I'm just going to say right now, if you leave the third one blank, I am not going to mark you off for it, because when I looked at it, I thought it was easier than it actually is. So I'm going to start you off, but I actually I did this one on a separate sheet of paper because it was really long. So if you, I think there's an important idea in 3 that I want to talk about, but if you skip it altogether, I'm not going to mark you off. Okay, so I'll give you kind of a break on that one. I can't even fit this whole thing in my